have a panel designer as well. So right now what we are going to do, so we are to make the programming. So for that, there is a CAPL browser. The version is 17. It is similar to the CANoe version only. And we have a we know about C programming, right? When we make the programming, we need to make the program within the loops. Okay, so the include of these are the variables include, and moreover, we have the environmental variables and system variables. What is this? What is the purpose? How we are able to access? Going forward, we will need to know. Okay, so because whatever the functions it is there, right? The variables you can do drag and drop, and you need to write the messages. What is the system variable? How you are able to access? So when it is interacting with some functions, right, we need to follow this format only. If it is a environmental variables, so it will follow the different phase. And here, this is a project folder view. Okay, where whatever if it is include is there. Okay, so if you include main some messages or any declaration you are doing, so that declaration will be getting here. And similarly, when you are making as a variable, so variable and the timer. So if you say if you're writing something, so here you will be able to access it directly. So what is a project view? And sim will like it is a programming, right? So once if you the program is completed, we need to do the compile. So if you give the compile, what exactly happens is it will be saved. It will be you usually get the warnings and errors. What are the failures you are making and what is the error you got? So all these details. So based upon this, you need to correct your programming. And when you save this file, the file will be saved in the format of .can. Okay, it always saves as a .can. Okay, that is the format it will save. So if I need to open the file, yes, already created, I can open the file here. So if these are the last used, so we can use any one file. And these are some program. This is some specific for the UDS kind of diagnostics programming, where you don't want to require like for understanding like how we are sending the specific information and what is the response that it is getting. So it is for the diagnostics. Similarly, we have the programming for a few of things like can messages. So you need to change the states of zero means ignition on, key on, KL30. So these are like you are able to see ignition key off means zero. It will be whenever you plus key on one. Two means if it KL13 or so like the values depends upon the value the state will be changed. Okay, so this will be the CAPL scripting, the backend, the front end, it will be the panel. Okay, so like if you need to set the engine speed, right? So you need to read the petrol values. So how you able to read? So those things. So here the programming will be there. So it able to access this information because this is kind of the can IDs are not working. Program is it will be clear, but if you're not making the interaction properly, so in the right window you are able to see that information. Here usually you will get it in the right window. Okay. So next point. So what are the options we have in CANoe? So in this window we have a options of so whatever you are able to see the mode here, this will be the complete browser window like what we discussed. So it contains all the functions or the specific to the events which we say on key, on start. Okay, so and on timer. Okay, so these are some part of a events. In interviews, they will ask you what are the events that available in the CAPL. So you need to give this some of this on key, on timer, on start, on message. So all this. In interviews, they will ask you what is the purpose of star. If you give on message star, what is happen? If you need to declare the on key, how you are declaring. like that they will ask you very basic interview level. So specific to the, sorry, these are specific to the events. Okay, so it at least means when you are before point the points which we discussed, like so our event means it is one event will be executed at a time. One event will be running at a time. Okay, so that is means if you do on key or on time, so one event you are able to see there are many events here. So, but it will be execute only one event at a time. So that's what the event it will be. Okay, next we have a programming section. Whatever the programming we are writing, so that will be within this space. Okay, so in interviews they will ask you in CAPL browser what are the options we have. So that time you need to give, like we have events under this. We are able to make on event, on timer, on message. All this we can do. And programming section is what exactly the program you are writing. This will be the window. And next we have a functions, because every programming language will have a functions. Okay, so what is the main purpose of the functions is, the functions is to perform some action. So the meaning of function is to perform the action. Okay, so what is the action it need to perform? So whatever it may be, so the task, so whatever the task you need to do, so that task will be performed with the help of this function. So that will be comes as a part of a CAPL function. So next will be the compiler output, means when you read the program here, right? So that program will be verified as a in the compiler output. Like as we saw, we are able to see the errors and warnings. Okay, so this is what the complete browser. It have four fields you need to remember. If in interviews they will ask you, so you need to give, because this will makes the interview okay that you know about this tool completely, and moreover the programming you know better. And if they give you the work, so that time you are able to do this activity. So that's the confidence you going to give to the interviewer. So these are the four options. So what are these here? So we already discussed. This will becomes as a part of event, and this will becomes as a part of the functions. So you are able to see there is a only the symbols here, right? So we have a symbols. Symbols is specifically talks about the system variables and environmental variables. So going forward, we'll discuss about this in detail. And next we have a CAPL functions. So this CAPL functions is specific to the handler like functions. So like we have it two things, the event handlers like a can, and moreover the system on key on start. Okay, so these are the functions. Okay, when we are writing the programming, right? So this is a kind of a project view. Okay, so whatever the functions you are taking, these are a function events. Okay, so it will come as a part of, so I took those function from on bus of. So in the project view we got a on bus of. So this is a events. Okay, so means for this programming, this is the activity it need to start. So it is a kind of the action that you are doing and created in the project view. And similarly, if I take the on error frame, this is a function. Okay, function event it is. Okay, so now my event is on error frame. So means event means the action it should take, that is the event. Okay, so this will be having a functions. So what are the events? It will be on bus of, on error frame, even on warning light. So this all will be considered as a part of the events that will be defined in the programming, where it will do some work, some action, some task. Okay, so in can we know about a bus of, like I need to create a bus of failure, and I need to uh, read the warnings in it. So how I need to take, so whenever you are making this action, right? So this is the action I need to do. I need to create a bus of. So within this you need to make the bus of, okay, short to the battery and the short to the ground, like you are going to make some program like this. So When you do this, it will happen through the programming interface. Okay, so like this is the action it need to be performed. So it will be the event, and if any failures, you cannot read it immediately. Okay, so once if you compile, you will get the warnings and the errors. Okay, so what is the error you are making, what is the syntax you are missing, so that you will get it in the compile. And one more important point, whenever you are writing the programming, right, you are able to see there is a small a, red line you are able to see. So this line indicates that you are missing some colon or some syntax. So you need to make sure that the colon is given, and still you are it is a yellow color, so it means inconclusive. It's still the whatever the program you written, it's not up to the mark. So it is an indication like your program is not ready. If suppose if I remove this completely, yeah, that's fine. Like moreover, it won't impact more. Okay, so saying that whatever the uh, s- command you are given, still it is a valid. Okay, so where you are able to make the programming. If you run right now, nothing is there. Okay, so there is no function, no event, just only the event is there. But what exactly this event should do, I don't have anything. Like whether I need to perform a plus a equals to b plus c. So that formula it should be calculated. Still, that is not defined here, right? So now if we do this, now if we do compile, you will get a zero warnings and zero errors, because the code is clear now. Okay, so this compilation is happen, and after this compilation we'll do in the, how it is interfaced to the CANoe is. So just it is in, we are creating this node here. Okay, so like right click and insert the CAPL node or insert the network node. So network node you can create. So because this is specific to the ECU, okay, so here this is the one you can create. And after doing this, it is asking us load the CAPL program .cacan. We can load other files also, but as of now, the can. So where is my file? So that the CAPL line, I need to load it. So once if I load it here, this whatever the messages you need to send, it will be sending into the network. Okay, so that's how the physically like will make it the programming in the CAPL browser, and we are creating the node in the simulation. From the simulation, we are able to, if you need to send the messages, right? So just whatever the network is there, so I need to send the messages to the network. So we are sending the messages to the network. And moreover, so it should be in 100 milliseconds of time, or it should be in 200 milliseconds of time, or whenever on key. So when you are pressing the key, whether you are sending or not. So that will be depends upon the CAPL program, whatever we are writing it. So based upon that only, so on this network, the message will be code. So what it will do, like if you say the message, you need to turn on the key, and the switch and light should LED should glow on this area. So the LED will be going, means this is a one say ECU2, this will be ECU1. So like this, you whatever the data you are sending, it will pass through the network, and it will based upon the ID we chosen, so it will work. Means, so in the programming like CAPL, we need to understand how we are sending the message to the network and how we are observing this. Okay, so that is all about in detail overview. Okay, so we'll understand in detail about this. So CAPL browser, it consists of all the um, pro events, programming field, and the function field, and right. Okay, and it is a very easy to use. Okay, so we have a GUI. So the backend, it will be the CAPL, and it is a much simpler to the C programming, whatever the events that we are triggering, and and moreover, how this DBC will be accessed. So whatever the messages or signals, so to load into the CAPL browser, we need to use the CAN DB plus editor. Okay, so can DBP plus editor should be accessed, and with the help of the can DBC plus editor, so it is easy for us to access the information. Okay, so like if it is this is a message, so where I will get the message, so we need to load the in the CANoe. If you load the .dbc file, so will show you how it will be accessed all those going forward. So with the dbc file, the message will be accessed via uh, the CAPL script. Okay, and next is what are the CAPL keywords? So the CAPL keywords are the events, system events such as on start, on key, key press, on the timer, software timer, can messages, canvas off. So these are examples. So on start is about the CANoe. On message is specifically you need to send the message whenever the message is on. Key press is whenever you are entering the key on keyboard, so that time it should be triggered. And on timer, on time whenever the response is getting, so that time you need to respond the same. And software timers, so because of the programming internally that it have the uh, variation and can messages and can bus off states. So these are some keywords we need to remember further. Okay, so going into the another concepts, next will be the whatever the programming we are making, right? So that are executed with the help of events. Okay, so whatever the execution we are making, right, within the variable or on bus of, so these are like a kind of a blocks. Okay, so it is a small program blocks. With the help of this only, the it will be executing. Okay, okay, you can write down this point. CAPL is a procedure language. CAPL is a procedure language whereby execution of program blocks is controlled by events. Controlled by events. If I say something, you need to write those points are should be appear in your notes. Okay, and when you do revision, it is important for you to read these points. Okay, is it clear?
Yes, sir.
Okay, so next point will be whatever the programming blocks that we are called as a event procedures. Okay, so you can told by the events. Next, the other point, so whatever the keywords we say, right, so these keywords are the variables and functions. Okay, going forward we can understand. Next, so in C programming, right, so like some of the common keywords we know about: break, case, character, continue, default, do, double else. These are some data types and keywords. Okay, so in the CAPL also it will be the same, like a few of the data types we are using. So we'll learn it further. And yeah, compilation is used for showing the programming error. So I shown you like how we are doing this in the tool. Okay, and next, coming to the other topic, what are the key aspects of CAPL program? So the purpose, and as I discussed, it is specifically for the ECU nodes to communicate within the network. Okay, so 1 minute. Next, so what are the specific syntax? So it is similar to the C++ programming languages, where the variables or the loops or the conditions as functions will be the same. And it's specifically used for CAPL is used for message handlings. Okay, so mostly for the communications of the network. Okay, within the network, the transmitter and receiver and how the data is exchanging. So for that purpose only we are using this. Okay, so next is a part of the one of event driven programming. So whatever the messages we are making, like on start on key. So that are the event driven. So for that purpose, whenever you going to interface, that it will be uh, the message should be sent on the network. And next is environmental interaction. So like we know about the panel. So panel, like we have a switch or any simulation activity that we are doing. So that will becomes as a part of an environmental interaction. With the help of this CAPL, we are able to do that. And next is a simulation control. So where we are able to start, stop, or some scenarios can be manipulated, can be changes we can do on the simulation control. Next is diagnostic services. So where we are able to debug the failures in the ECUs, so that we are able to operate via the CAPL. And mostly it is easy for the integration with the CANoe also, not only with CANoe. So if we can use for the CANoe also in the tool. And next is a logging and reporting. So in the like in the tool, we can take the log manually, right? So same way, like when we make it in a CAPL programming, like file open, file download site, like if you have some function, so where here also we can take those logging and reporting details in detail. So these are the some points where you need to go through on high level understanding of what is the purpose of the key programming. Okay, so what are the skills how you should learn before CAPL? So as I told you, um, the C programming, and moreover, you need to understand the CAN protocol. So because we are mostly dealing with the CAN messages and signals, right? So how the data we are sending, how we are able to communicate with the network. So you need to understand the CAN protocol. Yes, you are aware that CAN protocol and the message formats, the standard or extended, what is the ID, and how the what is the principles it will follow, how the data DLC will be selected, how the data will be flowing based upon the DLC, how the control field it will act. So those areas you are aware on the CAN protocol, right? So that you should be aware. And next is the programming fundamental, like the C programming, like so you need to understand the data types and some of the if else loop conditions and functions. So basic things, it's sufficient. It's we don't want in detail. And next is the automotive knowledge, because automotive knowledge is to understand one ECU to another ECU, how the data is communicating, like if airbag or engine, so how this is connecting with each other. So that should be understood. And moreover, you need to understand electrical electronics, because when you are dealing with the controllers, right? So you need to set the voltage or send the voltages to the other ECUs. So some monitoring things should be done in the when you are making the programming, like 480 volts, you need to draw the current. Okay, so if you are drawing the current 480 volts, right, it will be damaged the ECU. So you should be aware what is the voltage you need to utilize, 48 volts or 480 volts, or in terms of 4.8 volts. So you should aware about the voltages or the currents or the sensors, how it is able to access. So you know about the sensors and actuators. So moreover, you will get the kits. Okay, so we'll conduct the workshop. Okay, with the workshop, online workshop will conduct. Mostly from that time, you can understand about the resistors, and you can understand about the uh, so potentiometers and the sensors. Okay, how it is working, and what are the LEDs we are operating. So those things it will be given to you in the workshop. During the workshop, the kit will share to you. So hope you all are share the address to Bharat, right?
Yes, sir, share the full.
Yeah, share the address. So mostly you will get the kit delivered to your home, and make availability with the laptop. Okay, so laptop or system. So we'll conduct a workshop. So workshop is like specifically about the controller, and how it is interfacing to the devices and all. Like we'll discuss. and it is a kind of a small project. Okay, so where we'll practice all the components knowledge. You'll get hands-on experience on those things. Okay, so that is very important. You need to share your address to the Bharat. If you not share, please share it today. Okay, so you will get a hands-on experience how the sensors are working, how what is the actuators. Okay, so how the communication is happening between the system to your controller. It is like a complete project scope. Okay, so that you will get a hands-on experience, I can say. And you need to understand this. Next is about the tool like CANanalyzer or the vector tools, which you should be familiar. So you know about CANoe tool, right? So like same way, you need to understand about CANanalyzer also if you are using it. And data logging, like how manually we are taking the log in the CANoe. So like where we have a option. So similarly, we need to understand the high level, because the programming when you are making, you need to understand the high level, and then you need to go with the bottom level to what are the functions it involve, what you need to do exactly, and some of the debugging skills and the communication skills, and so requirement analysis. Okay, so all these are the skills you should be set as a part of a real-time employee. You need to work in the organization. Okay, it's not only for specifically for the embedded system who are working as the any job as a software or any organization. You should have a communication skills, that is a mandatory. And if someone give you the work, okay, you need to have the analysis is what you need to do, whether you are making a correct activity or not. So that analysis also it's required important to make the update. Okay, so next important is what are the characteristics of a CAPL scripting, what it will be. So the here we have, as I told you, the CAPL is a event procedure language. Okay, so whenever you press start or stop or keyboard entry and can message reception, timeout or timeout user. So this all we practice, right? When you press the start or stop, so the message will coming on the can trace window. Okay, and moreover the keyboard we have it triggering, right? So triggering is specifically you are making the pulses. Okay, so what is this happens is, so when you are setting the triggering to manually we have an option, and we have the periodic. So Chakri, can you tell me what is a manual and a trigger periodic, what you did here?
So manual means like how
Yeah,
the
manual is one
user
time we are sending, right? And
yes.
moreover, on key. So whenever you will press on key or on, like you, if you make an on key as E, so that time that trigger means that time the pulse will go one time. Okay. So parallelly, once this pulses is rises, right? So the message also, whatever the signal value it is there, no, that signal value also it will start. This is the signal value. This will be the triggering condition. Okay, so what exactly you are doing the periodic is when you set 100 milliseconds of time, right? So this is now my 100 seconds of time. Okay, so 100 milliseconds. So this is it is raised one time, 100 seconds, 100 milliseconds. This is very important, guys. The periodic understanding of the pulses. Okay, I will tell you in level. So like this is a trigger. This is very important. Okay, so this is a trigger pulse. Okay, whatever we are saying, like if we say periodic, right? Periodic. Who are aware on this CANoe, like who practiced on Saturday, Sunday, they knows this. So the periodic of 100 milliseconds. Okay, and manual is one time. Manual is we are sending only one pulse at a time. Okay, just 100 milliseconds means 100 milliseconds only it will send. Now periodic is 100 milliseconds. How this periodic is coming means it is triggering is I set it that 100 milliseconds. This duration will come as a 100 seconds. Now this is a on. Now it is off. After 100 milliseconds, again it will activate 100 milliseconds. Again, this will be off. So again, in 100 milliseconds, it will be on. So like this triggering we are doing. So what I am sending the signal. I need to send my signal, right? So what is the signal we send? Like EPS warning, right? So this is a signal we send. What is the value we send it? So we send it the value of 4. You can imagine like the value we sent as a 4. Okay, so my signal value here. My signal value, what will happen? So it will be parallel, it will be sent it. Okay, so during 100 milliseconds of time, this will be 4. Remaining time, it will be 0. Again, it will be 4. Again, it will be 0. Again, it will be 4. Again, it will be 0. So you're getting right. So every 100 milliseconds, the value is coming 4 and changing to 0. Again, it is coming to 4 and it is 0. And again, it is coming 4 and 0. You are getting right. This is, you can draw it. This is very important. You cannot get anywhere. Okay. So this is the signal value and the triggering. Okay. So what exactly? This is the time and this is the state value. State is like 0 and 1. State value. Okay. And next is the signal value. Is it clear? This is a part of the triggering. So whenever you are sending the message, right? So when you set the periodic condition, it will go like this way. Okay. Who didn't understood? Who understood? Can tell me, please. I need response.
Understood.
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 Okay, good. Who didn't understand? I will repeat again. No worries. Please tell me. So clear, right? If I ask someone, you are able to explain me. Akila, can you tell me what is the trigger we are doing? What is the time duration we are doing?
So, I mean, in the camera, we are giving the trigger. It is a,
Mm.
I mean, we can give periodic or manual. Periodically, we
Okay.
will set the time period. Uh,
Mm.
Whereas manually, we will give the, I mean, on key. We can give any key so that we can execute. We can trigger the.
Yeah, so good. So like what exactly we are doing, no? Whatever the values we are sending, right? Like five, like consider this is my light. Okay. So this my light is there. So it is a kind of a LED. Okay. So this LED every 100 milliseconds you should on off. You need to do. Okay. So when you do this timing, right? The duration, this duration you are missing it. So that time for it rises for 100 milliseconds time. After 100 milliseconds of time, it rises again. So it rising and falling. So like that, the trigger will act. Okay. So these are electronics, right? So where the value should on off should conditions should be happen. Okay. So hope you understood. Like we'll continue with the other activity. So these are the events, whatever the messages or the timeouts or timeouts is specifically for the fall and rising and user graphical interface, whatever the simulation we are making, it will becomes under a part of the environmental aware things. Okay. So it is like the C syntax and it is moreover the event driven. So what are the event driven is set signals, send messages. So it is like the same and the C programming. So we know like when you are saving the programming or developing the programming, it will be in a .can files. Whatever the format of the CAPL you are writing in interviews, they will ask you, you need to give that .can. Okay, CAPL file format. You can write down CAPL file format. CAPL file format. .can. CAPL file format .can. Okay, and another format is another format is dot sin. but don't give in interview .sin. You can explain .can only. Okay. So whenever you are doing this CAPL compilation, no, so the compilation file will be .cbf. We cannot see this file, but just for your understanding. Okay. So next will be a part of how we are able to access those messages. So with the help of the .dbc file from the CAPL browser, we are able to access the system variables and messages and signals. Okay, further we'll do it and we can understand. Okay, just for more info, I added .can and .sin, what it is exactly, common library function. So that are included. So these are some repeated information. Just we need to learn the CANoe CAN and programming blocks. So messages DBC CAPL program. So CAPL is a event driven. So this we know. And what about the periodic messages that we need to transfer? All this we are doing. So this is a CAPL program. For this, the interfaces are related to the protocols. So whatever the protocol we are using, right? The CAN, Arlene, Ethernet, FlexRay. Okay, all these protocols will be supported to the CAPL. And this is a GUI part where you are making the simulation setup, and you need to operate it. So the backend, it will be the CAPL program, and the timers specifically for the timers on start or the periodic timing, that whatever we are doing. So it will be comes under a part of the timers and start and stop. So this in the CANoe we have a stop and start, right? So whenever you are pressing start and stop, because these are tools, backend it will have a CAPL functions. So this CAPL functions makes the complete panel off on will do. And next we have a keyboard entry. So on key we made it right like manually. So that on key will help us to interact with the backend of the CAPL programming. So this all will comes under a part of the CAPL program where it includes many things to update the values. And coming to the activity, so the programming activity, what we are doing and what are the events. So as we know, the specific timers will be there. And whenever the timers, it will be the timeout. If you send the message of 100 millisecond, so that time only the message should go. So after 100 millisecond, what it should be off. So once that will be considered a part of a timeout. Timeout is, so you are sending the pulses at 100 milliseconds of time. After 100 milliseconds of time, it should be timeout. Timeout will be happen. It will be off. Again, it will be on. So so what is the duration you set to active, right? So that will be part of the timer where it's set. So once the timer is within the region, so after 100 milliseconds of time, it will be expired. So that will be expired. It will becomes under the part of the timer expire. So the first will be the timer event. And next will be the user press key. So whenever you are pressing a key, so that time you are sending. So who did practically on the CANoe. So when they will come to know on this. And next is a message. Once the messages is valid or invalid, so if you are sending, so that will be comes as a part of event. So the timer events and on key events and on messages all comes under a part of the CAPL event. And yeah, these are the 3 points you need to remember. So the top events. And moreover, CAPL, so time events is specifically for the software timers. So within the programming, we are making it. And the IO events is the keyboards on key we can say it is a on key. So that is the keyboards or the serial ports or the parallel ports related IO things, inputs and output. On messages, so if the messages is valid or invalid or the error or any fault is triggered, so that will becomes as a part of the on message. So these are the uh, CAPL events. Based upon this only, uh, we are able to interact with the ECU. Okay, so just I given the top few like message events, timer events, keyboard events, error frame, can control. These are the same like whatever I given within the bracket. So it will be the same type. And how we are writing the programming. So like very simple, like in the C, how we are declaring the int I equals to 100. Okay, so just what we are doing, just we are declaring it. Like what is the declaration and definition? If I declare int a, what is happening? Can tell me anyone, please? Int a.
So if we declare without any value, it is a declaration.
It is a yes. So now it is a declaration. So I'm declaring like, okay, my a is a value. Okay, so this a value is a integer data type. Okay, so whatever the value you need to write, you should always write with the help of integer. If I say like int a equals to um, embedded, okay, so it cannot, right? So it cannot take, this is not a format also. It comes as a part of a string. String is nothing but a characters. Okay, so the characters you cannot give to integer directly. Okay, as we discussed in earlier, the typecasting. Okay, typecasting is converting of one data type to another data type. Okay, so now not going in detail of this. So now whatever the integer a equals to declare as the value, the value of a is now it is a integer value. Okay, so this will becomes under a part of a declaration. And initialization means when you are assigning some value, like my integer 4 is, this is a assigned means just I allocated the value, like consider that. Okay, so just we'll take it. So if I say that int a, this is a declaration. What exactly in the programming will happens is when you do the integer data types is a 4 bytes, right? So these 4 bytes of fields will be created. 4 bits of, sorry, 4 bytes. So now what exactly will happen? This will be the 4 bytes. So each byte it have 8 bits, right? Is it clear or not? Each bit have the means I have a 4 boxes now. So when I give int a equals to 5, okay. So this whatever this now it is, I'm initializing it because when I created this int a, the boxes are created. Now if I give int a equals to 5, now whatever the a it is there, right? The a it have 4 boxes. In the 4 boxes, the value of 5 will be stored. Remaining it will be empty. It is zeros only. Okay, is it clear?
Yes, sir.
Yeah, actually now we are not going what will happen in the empty boxes. We are not using the memory. This comes as a part of the programming in the C. This is a memory consumption. That in detail we are that will be a kind of the bit stuffing or struct fields we use. Okay, so where to avoid it. Now it's not necessary to go in detail. Just to make you the box is ready. If the box is there, empty box, you need to fill that box as a file. Okay. So who not understood, I will repeat you again. If int a equals is just we are creating a one box. Okay. So in that box, you need to store the value of 5. That's it. Okay. Similarly here, when we make it like int int I equals to 100, right? So you created a box, and in the box you given 100. So that is what the declaration and initialization of the integer. And in case of character, it is also same. Like when you make a character a equals to sorry, character a, so that time the box is created. In the box you need to store like m, so that m will be stored in the box. That will be the declaration. This will becomes as a part of a declaration, and it will becomes as a part of the initialization. Why I am repeating is to understand you what is a declaration and definition and initialization. Okay, is it clear? So now it is a same, like here we didn't initialize anything. So just I given flow text. So that will be a part of a declaration. Okay. Now, so in C programming, we are using the printf, right? So printf is the one you need to see the output. Now in CAPL, in CANoe, we have a write window. Okay. So this write window is the output. Okay, for that to understand, like we have a write. This is the instead of printf, we are using the write and giving the link like to print the output. So what is the write of what it is reading? What is the I? It is 100. What is the in terms of hexa value? It is in decimal value. This percentage of d. When you are mentioning this percent of d, it will be decimal. When you mention the percentage of x, it will be the hexa value. Okay, so I need my a value in terms of decimal and in terms of x value. So when what it will be the this will be the decimal value. In terms of hexa value, what it will be? So for getting conversion, so how you will convert the decimal value to hexa value? Did you remember? Anyone? Is it correct? What I am writing? Response, guys. Did you forget it? So, did you remember this formula format?
Yes.
Okay. So similarly, when we count this 64, you will get a 64. Okay. So, so we're not going in detail as of now. The conversion under. So, and next we have the floating point. So same like if I have the PI, what it will get the floating point and the character. So ASCII characters and the value. So whatever the value you need to convert, right? So that conversion you can give as a part of the printf, but like percentage of f within the colon. So this is kind of a comment. It won't print outside. You'll print only this value and this. So these are very important two fields when you need to print some values. Okay, you can try to practice this programming. Okay, so I will share it later. So to understand, give some different values in the CAPL and try to practice it. Okay, so the output finally will be the 100. So next the other part, the first part will be the 100, and here we'll get a 64. And next we have a pi, because default pi value always, remember, it will be like a 3.14. Okay, so whatever the pi value, it will be there in the programming. Pi means in engineering, so you know about this pi. So it will be like 3.44, that value will get it. And next will be the character. So this is a ASCII character. Did you remember, like small a, it will be comes as a part of a 95, and capital A, when you give here instead of small a, if you give capital A, you get a 65. Okay, so like try to give some this is a kind of a ASCII table. You remember about the ASCII table, which contains the different symbols, right? Like it will have a 0 to 255 values in it. So that characters will be printed here. And next will be the right window. So right window is whatever the X here, if you see, This X we didn't initialize any value, just we declared it. So that value will get it as a 0. Okay, this is a small practical things. Try to make it a practice. Okay, so how you need to do. So like open the CAPL browser here. Okay, so here you can try to write the same. So integer, whenever you are writing, you need to write like a variable. Okay, variable. It is there already. Okay, sorry. So variable integer int a and a equals to, you can practice small way. Okay, so 3 and I'm declaring and initializing same way. My value is, so remember when you are writing within the programming, you need to write colon. Okay, so you need to ensure that within the tool, you should not get any warnings. Okay, so my value is, it should be percentage of D because decimal, colon, comma, and A will make it like this. So still I am getting some warning right here, some parsing error. Okay, we'll see like why it is we are getting it. And I'm compiling now. I'm getting that compilation file one warning. So when maybe I will tell you like later. So you need to write like this and do the compilation. Okay, and before doing this, you can compile it and you can practice like this. Okay, simple way. Just declare and try to print. This is a basic level to know about the characters and the integers, how it is printing. And next will be the part of the events. So we have the system specific events, and the system specific is the system and the can related and the errors, and the user defined events. User defines are the can messages, timers, keyboards, and the environment and functions. So this will be all comes as a part of the system specific events and user defined events. You can write down events, system specific events, user defined events, two types of events. So system specific events are system, can, controller, and error frame. And user defined are can, timer, keyboard, and the environment and function. Only you can write down this 1, 2, 3. The error frame until this. So just it is a continuation. So system specific events allows only to access a set of predefined CAPL events. Okay, so here duplicates are not allowed. And user defines are, we can create the unlimited number of user defined events. So this is a limited kind of thing system. Okay, so it is a unlimited where we create many. So you write down system specific events are system, can controller, error frame, and CAPL event. Sorry, the 3. You can highlight it. 1, 2, 3. And user defined are can, timer, keyboard, environment, and functions. Okay, getting right, you are able to understand what are the specific points you need to remember. So, like we are always continuously discussing about the CAN messages, timers, environment, functions, and errors, right? So this is differentiated into two ways: the system specific and user defined. Okay. So next is the brief info, like whatever the systems we have, pre-start, stop measurement, it will be like this. The whatever the events, it's system specific or user defined. So system specific are this, and we have the user defined. So whenever you are defining, right, the system specific should be a pre-start, stop measurement, bus, error active, error passive, warning limit. So coming to user defined, so we are defining the timeout. We can define the on keyboard detection. All those things we are making as a user defined. Okay. So going forward, you can understand. Now CAPL program is defined into whatever the programming we are writing, right? It is defined into two ways. One is a global variables and local variables. So what is that global variable? So global, whatever we are declaring and defining, right? Like initialization we are doing in the global variable. So that we are able to access through the program, and whatever user defined functions means we can do the programming uh, on our requirement. Okay, so the declaration and definition of the user defined functions and the event procedures. Okay, you can write down this. Declaring and definition of global variables, and declaring and definition of user defined functions and event procedure. So generally these are the two parts. Next is event. So the event means some task or action. So how it will take the priority. So event don't have any priority. Okay. So generally it won't take the priority. So whatever we are defining in the order, so whatever the program when we are making, right, so it will be executed in order only, the program. So here also it will execute if the condition is right, it will execute. If it is not, it will stop. It will skip, or some moment it will interrupt. It will go into the another jump again. It will complete. It is a kind of an interrupt where we this where it will stop and where it will be continue. So that will be defined in the program. So accordingly it will act. Okay. So is it clear? So now the important point of the event handlers. So whenever we are start and stop the button, we are playing, right? So that we called as a start of measurement. Okay. So what is this start of measurement is like we are starting the measurement and we are stopping it whenever we need to continue or we need to drop out. And moreover, the message receives whenever we are sending the messages on the network. So based upon that, whether the messages should receive or not. So that should be verified, right? So for doing that, message received will do. And signal changes. So whether the signal value is 3 or 4 or 1, 2, so that values whenever you received, that will be verified. And moreover, the event time means what is the time it is taking, whether it is 100 millisecond of time or 50 milliseconds of time. So that will be comes under a part of the time events. And key press. So whenever you are pressing the key, so that time should go like it will be on a part of the keyboard. But exactly how it is happening, what are the functions, it will be defined. So the first on start will be comes under a part of the on start and right window. So you will get this. And on message 0x123. So just you will whenever the message receives, you will print this. And whenever the signal is received, a specific signal, you will print this. And whenever the timer is activated, you are going to print this. And whenever you press a key on key, so the value will print. Okay, what is your activity is like tomorrow we will discuss all those other events further. So now what is your activity, what you need to do? So just we'll take on start. Okay. So and on key. Okay. So then these are the two fields you need to consider now. So now you are familiar with the CANoe tool, right? So you can make it better now. So now what you need to do, just here, within come here, just include, we have two fields, include and variable. What you need to do, gives on start. Okay. So on start, enter colon. So here you can write the function saying that measurement is started. You can write like this small program and close the colon. So now I don't have, it is inconclusive. Okay, because we didn't save it. Now I need to save this. So I will save it on my desktop, else I can go to the folder and make it an CAPL. So script, yeah. So just I will make it here as one. So just I make it as a batch one. So here just I saved my, after saving it, you got a green, means it is saved. Now you need to compile. So there is no warnings, no errors. So my file is saved. Okay. So where is my file path? You can go make it a save as, and you can take the path if needed. So then what is the next step you need to do? Go to the CANoe. Okay. So next you need to right click and insert the can block. Okay. So network node you can insert. So once then you remember, insert the network node. Okay. So network is specifically ECU. So here just double click it. So it will ask you the file. Okay. So now my path I given. So I'll save like a batch file. I open it. So default before, whenever you are loaded, right? So it will ask you whether your code is correct or not. So just save it and compile it again and close it. Okay. My file is loaded here. Now if I do, right, uh, start. Okay. So whatever I mentioned in the right window. Okay. So in the programming, I told that the right window, you should get the measurement. Okay. So measurement started, it came this information. Okay. But not sure like whether it is correct or not. Okay. So what you need to do, just stop it again and click on the simulation node. So under the simulation node on the network, you don't want to open the file under, just click it, the same node, double click it, the CAPL browser, whatever the programming you written, it will open. Okay. So now what you need to do, just make my measurement started here. I given no. So I am here. I can mention like I am here to help you. So like I given this command. Okay. So just I'm saving it again and do the compilation. So after doing, just minimize it. Don't get, because the file is already in the node, right? We don't want to do it. Okay. Just compile and state and run. So here it keep printing, I am here to help you. So means whatever you are making the programming in the node, so that node is started communicating with the network. Is it clear for you all? So now what is the next step you need to do? You need to make on key and A. I will press like A. Okay. So just save it and compile. Okay. So my compilation is done. So now if I do again off the CANoe and on the CANoe, I cannot see I am here to help you. What is this is a command, right? I given I am here to help you, but still I'm not able to see. Now here, if you able to see my arrow here, if I press A, now it came. The sentences came here. If again I press A, again it is coming. If I press A, again it is coming. So how many times if I press, that many times A is coming and printing is coming here. So means it is transferring one time. Okay, is it clear?